Hey guys, welcome to Empty Stack and you are watching LeetCode series of problem solving using Java, and today we are going to look at majority elements. To solve this question, it is good to have knowledge on arrays, hash table and sorting. The difficulty level is easy and the question was asked in interviews for companies like Google, Apple, Amazon, Uber, etc. Okay, let's jump into the question. We are given an integer array and we need to return the majority element, that is the element present in the array more than n by 2 times, or we can say more than 50% of times. We can assume the array will always have a majority element. For example, in this array of size 11, we see that 4 occurs 6 times, so it is a majority element and we need to return it. For better understanding, let's rephrase this problem statement. Say each number in the given array represents a candidate participating in the election. So here in this example, we have 4 unique numbers 1, 2, 3 and 4. So we can say these are the 4 participants standing in the election. Now let's say the array itself represents the voters. So each element in the array represents the vote casted by a person to certain candidate standing in the election. So here we see that the first person voted for orange, second voted for blue, third person voted for green and so on. Also, we know that the winner of this election won by a majority by getting more than 50% of votes. And what we need to find is who won this election. So in this example, we can say by looking at the array, the yellow candidate won the elections. Sounds good? Now let's try to form an approach to solve this question. What if we start counting the votes casted to each candidate? That would mean is we take the array of votes and create a table where we keep vote count of each candidate. From this, we can see the first candidate got 1 vote, second one got 6, third was given 3, and the last one was casted 1 vote. Now we can see we can rewrite this as a hash table, where key represents each candidate and value represents the count of vote casted to each candidate. Let's form an algorithm. We define a hash map and 2 variables, one to store the leader who got the majority and another one to store the count of vote casted to the leader. And now we iterate over the votes array. Now in each iteration, we want to insert in the hash map with candidate V as the key and count as the value. For a new candidate, the count can be set to 1, but we want to increase this count if the candidate was already present in the map. So we write a condition: if map is already containing the candidate, we get the current count from the map and add it to the count variable. What this will do is it will increase the current count by 1. Once done, we put the updated value back into the map. So far our table is ready. Now we also need to keep track of the leader, and for that we need to check who is getting the maximum votes. So we keep on updating that value as well. So if current count is more than max votes, we update max votes to the current count and we make current candidate as the leader. And that is it. If we talk about complexity, the time complexity will be O of n and space complexity would be O of n as well, as we are using extra space in form of hash map. But if you notice in this approach, we are not taking advantage of the condition that the leader is always going to get more than 50% of votes. Let's try to use this info in our next approach. What if we sort the voters on the basis of candidates? So all yellow voters comes together, all green comes together and so on. When sorting, it doesn't matter which color comes first. But if you notice, since more than 50% of votes are casted against only one candidate, in the sorted arrays, the middle element will always be a vote to the majority candidate. So we can form an algorithm. Firstly, we sort the array and then we return the middle element from the sorted array. So we can write votes.sort. Next we get middle index by dividing length of the array by 2, and finally we return this middle element from this array. And that is it. The time complexity will be O of n log n because of sorting, and the space complexity will be O of 1 as we are not using any extra space. If you see, we have improved on space complexity in comparison to our first approach, but the time complexity has gone worse. Let's try to build an approach which could solve the problem in O(n) time and O(1) space complexity. Let's say there are only 2 candidates standing in the election. That is, voters can give their vote to only these 2. Now if I choose any 2 random voters who voted for different candidates and remove them from the array, that means their votes won't be considered in the election. Will it have any impact on the result? No, right, because we have removed one voter from each side. If I keep on repeating this process, still there won't be any impact on the result, as at the end, one extra voter would still be left on the majority side. But what if we try to do this for 3 candidates? Again, if you remove 2 voters who voted for different candidates, the result won't be impacted. Doesn't matter which 2 voters you eliminate, as long as they have voted for different candidates, the result stays the same. And at the end, you would only be left with voters who were making the majority. Same thing you can try for n number of candidates. You can see the results are never impacted as long as you are removing voters voting for different candidates. So we can say if we remove voters voting for different candidates from the array, majority leader would still be the same. Using this fact, let's try to build an algorithm. What if we start from the first element of the array or the first voter and iterate towards the last voter? At every step, we keep track of 2 things. First, who can be a potential leader, and secondly, by how many votes. So in this example, we see that the first voter voted for orange, so we can make orange as a potential leader, and that by 1 vote. We move to the next voter, we see that he voted for yellow, and we established a while back if 2 voters voted for different candidates, they can be eliminated from the election without any impact on the result. So we can remove both of them. Doing this will reset the value of current leader and count will go back to 0, and now again we see we don't have any potential leader anymore. We move to the next voter. This person voted for green, so we make green as the new leader by count of 1 vote. Next voter also voted for green, so count will increase to 2. Next one voted for yellow. This guy voted for a different candidate, so again we can eliminate the last 2 voters. So vote count will go down by 1 as we have removed one green voter 2 from the election. We move to the next voter. Again this one didn't vote for our current leader green, so we can ignore these 2 voters too from the election and reduce the count again. The count will be reset to 0 and green will not be considered as the leader anymore. We move to the next voter and we have a new leader, yellow. Next 2 voters also voted for yellow, so we keep on increasing the count, which would finally be 3. Next we have a blue voter. This is different from the current leaders, so we can remove this and one yellow voter from the election. The vote count would decrease by 1 and we move towards the last voter. This one also voted for yellow, so again the vote count will increase by 1. Now since we have reached the end of the array, so we can say the leader is yellow who won the election by making a majority. Now what we did just now is a famous algorithm called Boyer-Moore's voting algorithm. Let's just restate the facts we saw about this algorithm. Firstly, if we know for sure one of the candidate is indeed in majority, that is getting more than 50% of votes, we can cancel out each non-matching votes. Secondly, in worst case even if all votes are cancelled out, we would still at least have one extra vote for the leader who is making majority. And last thing, while iterating over the array, we keep track of 2 things: the current potential leader and the count of votes by which the leader is leading. Now let's try to write an algorithm for this. As discussed, we can start by declaring 2 variables, one to store potential majority candidate and another one to store the count of votes casted to this leader. Next, we can iterate over the voters. In each iteration, we check if leader vote count is 0, then we can say the current vote will be the decider for the leader. So whoever the current vote is casted to will be considered to have majority and will become the potential majority candidate. Next, we check if current vote is casted to potential leader. If so, we can increase the leader vote count by 1. If vote is casted to someone else, we know we can cancel out 1 vote from the leader. So we add an else condition where we decrease the leader vote count. To reiterate, this section of code will only be called if current voter is not voting for the current leader, and when this happens, we decrease the leader vote count by 1, representing the vote cancellation. And finally, we return the potential majority candidate, and that is it. The algorithm is ready. Let's look at the complexity of this approach. The time complexity will be O(n) as we are finding the leader in single iteration, and the space complexity will be O(1) as we are only using constant space in form of 2 variables. Let's look at the Java solution. So we are going to use Boyer-Moore's algorithm. So firstly, we define 2 variables, potential majority element to store the leader and leader count to store the count by which the leader is leading. Next, we iterate over the input array, and in each iteration, firstly we check if there is no potential leader, that is the value of this variable is equal to 0, we can set the current number as the majority elements. Next, we check if current element n is same as the majority element, we increase the leader count by 1, else if they are not same, we decrease the leader count by 1, and finally we return the potential majority element. Let's run this. Perfect. See you guys in the next one.